Okay, this podcast is about solving triangles when you have information about side-side angle, so two sides and a non-included angle. I want to first remind you really quickly about things you learned in Geometry A about side-side angle and why it's not a congruent shortcut. So here's a really good example. In this triangle, I've got a side of 6 and a side of 10 and an angle 30. If I got this compass set up, if I draw this thing, I could have the exact same information and have that side over there. So there's two triangles that could be formed with sides 6, 10, and 30. That's one situation. So we don't use side-side angle as a congruent shortcut for that reason. Here's another picture. Here's a triangle. This side's 5, this side's 10. The angle's still 30 degrees. If I try and draw that, there's only one place where that 5 can be. In fact, this triangle you should recognize is a 30, 60, 90 triangle. This would be a right triangle or right angle down here, and this side. So this was what we would call in HL. So I've got HL information here, and in fact, I could only form one triangle out of that information. Here's another situation. What if I had this side is 12, that side's 10, and the angle is still 30 degrees. Well, if I rotate this side around or draw the other place where it would hit that line, well, it wouldn't hit that line on that side. It would never hit the line. And if I try to rotate this side around, it would land outside. It would mess up the 30-degree angle. So this triangle, I can only form one triangle with this information, 12, 10, and 30 degrees. Here's a fourth ridiculous kind of situation. What if the side is really short, like this 4? Well, it just wouldn't hit this side at all. So I'd have 0 triangles that could be formed there. Okay, so I want to quickly go on and actually solve some triangles of this situation. So the first thing you do is you draw a picture. And here's the picture of 13 degrees. This side would be 12. So here's my bad drawing of this triangle, but this side over here, this is side P. This angle P is 13 degrees. Side P is 12. And I'm going to make this Q, and this is 5. I'm going to set this up using the law of cosines. So as you remember, the law of cosines says something like a squared is equal to b squared plus c squared minus 2 times a times 2 times, let's get this right, 2 times b times c times the cosine of angle A. That's the pattern. Well, we've got P's and Q's, and up here we've got, in this triangle, we have an R up here. And this would be side R over here. So let's fill in the things that we can fill in. If I have, the only angle I have is 13 degrees, so that's got to go over here, cosine of 13 degrees. And the pattern is that if angle A is over, if angle P is over on that side, side P has got to be across the equal sign over there. And then I fill everything else in this picture. P 5 squared plus R squared minus 2 times 5 times R. Now, if you look at that, that is a quadratic equation. And we just put the quadratic equation on our calculators, our quadratic formula program, and we're going to use that. Here is how I'd rewrite this equation. This is cosine 13. Here is R. I just subtracted 12 squared from both sides, so I have it like that. In the quadratic formula, this is now in quadratic form, where the coefficient of the squared term is 1. The coefficient of the linear term, the R term, is negative 2 times 5 times the cosine of 13 degrees. And C is 5 squared minus 12 squared. And notice I'm not multiplying these things out. I'm not figuring out what 5 squared minus 12 squared is because I don't really care about that so much. So now I grab my calculator and I go to the programs and I choose this quadratic program that we just programmed in. And when it asks me for A, I put in 1. And when it asks me for B, I put in -2 times 5 cosine 13. And I put in 5 squared minus 12 squared. And I get this. And now the variable in this equation was r. So the results of the quadratic equation are telling me what r is. So r is equal to, got to find those numbers again, 16.8, 16.8, or r is equal to -7.0, I think was 0.8. Well, r can't be negative, so I get rid of that. So what this is telling me that I've got one triangle. The r side is 16.8, and I got that given information. Now I would find angle Q by doing law of sine. Sine Q over 5 is equal to sine 13 over 12, and sine Q is equal to 5 sine 13 over 12. Angle Q, I'm going to calculate that on the calculator. So I do 5 sine 13 divided by 12. Take the inverse sine of that, and I get a syntax error. Second answer, and I get that, 5.4 degrees. So this is 5.4 degrees, and angle R, I'm going to find by subtraction 180 minus 5.4 degrees minus 13 degrees, and that is 180 minus second answer minus 13, 161.6 degrees. So angle R is 161.6 degrees. So my complete solution of this triangle is these three pieces of information. Make sure it's clear. Okay. Set up the next problem the way we did up here and see if you can use your quadratic program to come up with the R values, whatever R values you find. I'm going to let you do that. Okay, I finished solving this problem, and I solved for both triangles, and here are my two different R values. R is equal to 3.1, or R is equal to 26.1 in that triangle. I solved the rest of the big triangle by using the law of sines, got 16.3 degrees for Q. I subtracted to find angle R and got 150.7 degrees. And then I drew a new triangle. I used the other value that I got from the quadratic formula, 3.1, as another possible side for side R, 3.1. And then I found the small angle R, got real small angle, 3.3 degrees. And angle Q is 163.7 degrees I found by subtraction. That's it.